Here's a video for one of the problems from section 6.3, and fair warning, it's not even 7 a.m. and I'm still drinking coffee, so this one may not go so well. We're trying to revolve a region around the y-axis, so like with all the problems, it helps to have a good picture of the region. It would be nice if I could draw a good picture of a region, but let's see if I can draw a straight line. Not really. All right, so our region is given by the equation y equal the square root of x over 2. The square root function looks kind of like this. It's a positive part of a sideways parabola, and they tell us that we're going from y equals 0, which is the x-axis, will be the bottom of it, and x equals 2 will be one side of it. So it's the region that's created between the curve, the vertical line x equals 2, and the x-axis. And they ask us to rotate it or revolve this region around the y-axis, which means that in order to get a washer-shaped, to get any kind of circular cross-section, we need to slice the the region horizontally. All right, so when we slice the region horizontally, that means that we're picking a y value to decide where the slice goes. Oh, I forgot to label this. So this is y equal square root of x over 2. This point right here, that's pretty easy to find because we know the x-coordinate is 2. And so then we can just use the equation to find the y-coordinate. The y-coordinate of the parabola part is square root of 2 over 2, so 1. So we're slicing at a value of y, and the y's can be down here as low as 0 and up here as high as 1. So I know that good Lord, I know that the values of y that will make sense in my picture are y's between 0 and 1. All right, so it's coming along pretty well. What I keep doing in class, and I hope that you will see some value in this, is that I just label the points on either end of this rectangular stick that I'm going to revolve around the y-axis. I'm going to take this stick and it's going to spin around this, and that's what's going to lead to a washer shape. But to label the dimensions of that washer, I need to first label the ends of the rectangle in my 2D picture. So this end of the rectangle, well, we're told that the x-coordinate there is 2 because it falls on this line. Oh, what I did there. Can I even erase that? Yeah, okay. Oh, I see. I drew a tick mark through, and then I put a 2 next to it. It looked like a 12. Anyway, we're told that everything along here has x-coordinate 2. So the right-hand side of my rectangle will always have x-coordinate 2. And the y-coordinate of this point, well, that's just the location of the slice. So that's just going to be labeled y. On this side, if I can draw an arrow to it, on this side, again, the y-coordinate's y. That part is coming from the location of the slice, but I need to know the x-coordinate. And so this is where we keep having issues where if we're slicing horizontally, we are very likely to need to know the equations of our curves, not in the form y equals something in terms of x, but rather x equals something in terms of y. And so that's exactly the case here. I know my y-coordinate's called y, and I want to try to figure out what my x-coordinate is, but I need to write an expression there for the x-coordinate also in terms of y. So I would have been well advised to do that in the first place, but here's the way that parabola was given to me. And so I'm just going to solve. So solve for x. So you treat that as an equation, you're going to solve for x. If I square both sides of the equation, I get y squared equals x over 2. Multiply both sides by 2, and I'll get 2y squared equals x. So these equations are equivalent. Well, almost. This one only allows y's to be positive, and for this one it could go both ways. So this is only giving you half the parabola, and this is giving you the whole parabola. But we don't care because we're only worried about half of it anyway. But this will give us the, this describes x coordinates in terms of y coordinates. And that's exactly the case where we have here. I know my y coordinate is the location of the slice, and then my x coordinate can be found by multiplying 2 times the y coordinate squared. So now I have a completely labeled picture of my 2D region. Now what I want to do is draw a picture of a slice. And like we said before, rather than revolve the region around and try to draw that and draw a slice of it, it's equivalent to just think of this one slice of the 2D region and what it looks like when it spins around. It'll be the same thing. So this stick, when it spins around, is going to give us a washer shape. The center of rotation is going to be right in the middle. So this is a washer, so it's a disc with a hole punched out. But just to line things up, the center of this cross section is right here. That's coming off of the axis. The axis of rotation gives us the center of this slice. So when I'm trying to label a washer, I have to label two things. I've got to first label, well, not first, but I have to measure two things. I have to measure the radius of the hole, and I need to measure the radius of the whole thing. So the radius of the hole is the distance from the center of the hole, which is here, out to the first edge of the rectangle that I find. So from here to here is the radius of the hole. So the x-coordinate of this point is 0. The x-coordinate of this point is 2y squared. So the distance from there to there is just the difference of those two x-coordinates. The one to the right, the bigger one, is this one, the 2y squared. So technically, 2y squared minus 0, so the distance, but since you're subtracting 0, that makes it easier. So the the radius of the hole is 2y squared. Now I need to know the the big radius, the radius of the entire object. And again, that's a distance from the center, here's the center, all the way out to the far edge of the washer. So the distance from the center, y 0, y, out to 2, y. Well, it's a little weird, but that's always 2. The distance from 0y to 2y is always 2. No matter where we draw the y, the the center will be at y0 or 0y, and the outermost edge will be at 2y. So strangely enough, the outside radius of this so the radius of the whole thing is just 2. And so that's all we need to know to find the area of a washer. Remember, our estimate for volume is just the surface area of the cross-section times the thickness of the cross-section. So the volume of one slice is going to be approximately the area of this thing, which is, we do pi times 2 squared. That's what the disk would have been if it didn't have a hole punched out of it, minus the area of the stuff that was punched out to form the hole, times the thickness, and we write the thickness in terms of y as well. So small change in y will be our thickness. That means that our integral that answers the volume of the whole problem is just pi times 2 squared minus pi times 2y squared dy, and the possible values of y, as we said before, are going from 0 to 1. So this is this integral is perfectly good. You'll see that they almost always will write that with the pi already factored out, just to save you that algebra step in every problem. But again, like I keep saying, it's not like we have to do a dozen of these problems, in 10 minutes. So being understanding what you're doing is more important than having the most efficient formula. But don't forget when you evaluate this integral here that don't get bogged down by the parentheses. Just go ahead and do the algebra before you integrate. So 2y squared squared is 4y to the fourth. Obviously, this is just 4. So by the time you pull the pi out and square the stuff that's inside, this is actually a fairly simple integral to complete.